This is the first lesson in the series of remote sensing analysis, and I am using Snap Desktop developed by European Satellite Agency ESA. So we can download the software Snap Desktop from this website, and I have used only Sentinel toolboxes, and my computer is Windows 64-bit, so I use this link to download the software. So the next thing for the analysis of remote sensing data, we need to download the data. So for that purpose, we need to define the region of interest. So I have created the region of interest in QGIS, and it is GeoJSON file, and we can see this area. So there are two ways to download the data from which is operated by European Satellite Agency, and this is the website which is also mentioned in the description here. In this website you can find the description where to download. So this is the another chapter. It is landslide susceptibility mapping, but in the data preparation I have mentioned how to download the data. So another option is using this Python programming language. So if you know the location of your data and you can draw it on this map shown by this, then you can just follow this tutorial. Otherwise, we can use this code to download the data. So I'm not going to show this code, how to work with this code. So in this, I will only explain. We read this GeoJSON file and pass our username, password, and the criteria like date from 23 May 1st to May 30, and cloud coverage between 0 to 20, and the platform is Sentinel-2. It is exactly same that we can do here, like we can check Sentinel-2 and here platform, etc., and get the data as mentioned in this tutorial. So after that, I open this Snap Desktop. We can see these menu and toolbars. So the Sentinel data downloaded is here in my folder. So this is unzipped data. So but you can directly use the zip file also, but I am going to use this unzipped data. So and I have created this extent, and I have exported it to shape file because Snap Desktop cannot use another format. So I use the shape file here. So first of all, I open the product, and before that I create a new project. So new project, and I name it RS analysis, and or I have already created, so version 2. So RS analysis version 2, and now I open the product, So inside this SAFE file, you can see this mtd something dot xml. So if you double click this one, in a few seconds the data will be displayed. So we can see that the data is already displayed. So if we see the data, we can display the data under the bands. If you want to see more information, you can check this product general info, product info. So you can find so many things here, but I am not going into detail about these things. So I will tell you how to display the data. As you can see in this displaying the data. So I'll in detail I will show you how to display, but basic way to display the data is like this. You can double click and it will show here, and you can close it like this. So I need only the data of the region of interest, which I show you here. So we can display the vector data here. So import, and we use ESRI shape file, and I have this shape file here, and I open this one. So we can see that the data is displayed here. So I will clip the data to the extent of this region of interest. The bands have different resolutions. Band 2, 3, 4 and 8 are 10 meter resolution, and others, some of them are 20 meter and some of them are 60 meter resolution. So I want to clip this data to the extent of this. So there are various ways to do that, but what I do is I zoom the data to the extent of this area, and I make it and using this hand tool, so little bit bigger than the intended region of interest. And then so first of all I subset is same as clipping in GIS. So there are two subsets, so we can use raster and subset. And when we show this data extent, it will automatically tell you the extent that you want to clip. So if we use this, then it will clip the data to the extent visible here. So we don't need to change anything. So if we check B2, then the size will increase. But we want the reference band to lower resolution data, so like B5 or maybe B6 or B1, which are lower resolution data. And in this exercise, I want only few unselect few bands. So first of all, I select none, and then I select the required bands. So this is band subset, spatial subset and band subset. So B2, B5, B6, B7, B8, B8A, B11 and B12. So I have skipped some of the data below, and then OK. So we can save. So the saving the data will create a beam DMAP format which is used by Snap desktop. So we use this folder. The subset we can name it. It is a very big name. So I delete some part of it. I only want to keep the date part. So I save this data. So I close all the products and I don't save the original because it wants to save with this vector data, and I say no. And again open the newly created product. This is the newly created product, and if we double click this one, it will be shown here, and band names are same as before. So we can show the subset like this. So this is the area of interest, and I can again add this uh, vector data here. So it is the area of interest, but I will do the analysis for whole the area. So we can display or hide the layer like this. Uh, Now let us view some bands. So band B2, B3 and B4 are higher resolution along with B8, and B4 is a bit, B5 is 20-meter resolution data. So to compare these two bands, we need to display both bands. For example, we can display uh, we can display horizontally. So this will be displayed like this, and when I move this, then it is also moving in the same way. Because I have checked in this navigation, I have clicked this one, otherwise it will move independently. So if we make it synchronize, then both the images will be synchronized, and if we zoom, then it will be zoomed together, and we can see that the B2 is very sharp compared to B5, which is not so sharp. And this B8 band is near infrared, and it is also sharp. So we can see this again tiled horizontally, and we can see that B2 and B8 are very sharp images, while B5 is lower resolution data. So this is how we display the data in this remote sensing canvas, just by double clicking here. And now we display the RGB. So right click here and open RGB image. So it is natural color. So B4 is red, B3 is green, and B2 is blue. So Now again we can see this color, and for example we can manipulate the color. So like this it becomes sharper, and so it becomes very dark. So the data is up to here only. So this is the tentative histogram. So by sliding this part we can change the contrast of this image. So in the case of RGB we have three different colors. So currently it is displaying up to this range. We can increase or decrease the range for each red, green and blue. So it works in the similar way as the single band. So we did this spatial subset, band subset, and displayed the single band, displaying RGB band, and we also did this color navigation, and we already moved the image using zoom. Zoom can be used by the mouse wheel, or we can use this tool when we hover here. So this will move it, and if we move this one it will zoom, and also we can use this navigation tab to change the location of the map. So this is how we work with Desktop. These are the basic operations. In the next video I will tell what kind of things we can do with this data.